Hello everyone, welcome to this video, and in this video we're going to discuss about set operation. When we talk about set operation, let's go about the two models of set. Example given, set A, set B, and a universal set. The first model that I'm going to present is what we call the disjoint set. The disjoint set is there is no common element between the two sets, such as set A and set B. Let's have an example. Given the universal set with an elements of 1, 2, 3, 4, 5, and then set A has 1, 2, 3, and then set B has 4 and 5 as its element. As you can see, when you observe now set A and set B, there are no common elements. Let's have another model. Another model is known as joint set. Now, in this joint set, as you can see, there is an intersection between set A and set B where the common element is located. Now, let's have an example. In the example, we have the universal set 1, 2, 3, 4, 5. Now, set A is 1, 2, 3. Set B is 3, 4, 5. As you can see, there is a common element which is 3. So this is 3. Where is the location of 3 in the set? Now, as we discuss the operation, let's look at now some more examples. Let's have now some set operation. The first one is complement. The other one is union, intersection, and then difference. Let's talk about complement. Complement, given a universal set and set A, complement of A is denoted by A prime, so read as A complement or A prime. Let's go now on an example of this one. Let's explore. Given this model, where we could look at this one, this is now the universal set. Everything that contains in the rectangle are the elements of the universal set, while elements inside the circle are the elements contained by set A. Now, let's have some example. What are the elements of the universal set? The elements of the universal set are 1, 2, 3, 4, and 5. Let's have now the elements of set A. Now, let's look at now the circle and then identify now what are the elements of set A. Upon looking that, we have now set A has an element of 2, 3, and 5. Let's continue our exploration. Once again, this is the image. Now, the question is, what are the elements of A prime? Now, as you can see, these are the elements of A. What are the other elements that is not included in set A? So, as you can see, that is 1 and 4, where they are located outside set A. Now, let's have now another question. Another question is, what are the elements of A, complement of A, and then its complement as well? So there are dual complements. So knowing that A complement is 1 and 4, what is the complement of 1 and 4? Which is the elements that is not included 1 and 4? So therefore the answer is, the complement of A is 2, 3, and 5. Let's proceed now to another operation known as union. Given set A and B, the union is an operation combining all the elements of the set. It is denoted by A union B, read as A union B. This is the symbol, and this is how it should be read. Let's model now a union. So as you can see, we combine now all the elements of set A and set B, even though they are disjoint. So as you can see, we contain now all the elements of set A and set B in one set. In another model, we have now the joint set where set A and set B, we combine all the elements from set A, set B, and its intersection. Let's explore now union. Now, given now this one, as you can see, this is our new set. So let's have some question. What are the elements of the universal set? So let's look at now the whole elements that it included on the rectangle. So as we can see, the set is 1, 2, 3, 4, and 5. Now, let's talk about what are the elements of set A. So let's look at now the circle of A and what are its elements. As you can see, here are the two elements. So we could answer set A is equal to 4 and 5. Another question is that what are the elements of set B? So as you can see, this is now set B. The elements are 2 and 5. So we could say that set B is 2 and 5. Now, let's have now what are the elements of A union B. Now, we combine now all the elements of A and all elements of B. So, we can see that these are the three elements. No repetition of what is the intersection. We take that as 1. So, therefore, A union B is 2, 4, and 5. Let's have another operation known as intersection. Given set A and B, the intersection sets are the common elements of the sets. It is denoted by A intersection or reverse U as a symbol B. It is read as A intersect B. In a model of a joint set, since we need to identify the common element, we only answering what is the intersection or the common element between two sets, which is A and B. Let's have the exploration of intersection. Now, given now the model, which is this is our model, the same model that we use in the union. So, what are the elements of the universal set? So, technically getting all the elements inside the rectangle. So, 1, 2, 3, 4, 5. Now, what are the elements of set A, which is the elements inside the circle of A? So, as you can see, that's 4 and 5. What are the elements of B? So, let's look at that. That is now what the elements inside circle B, that is 2 and 5. Now, let's look at now what are the elements of A intersection B. The elements of A intersection B is 5 because this is the only element that is included in both, that is common between set A and set B. Now, let's have now difference. Difference, given set A and set B. The difference is the remaining in the minuend of the set operation. So, it is denoted by A minus B, read as A minus B. Let's have now the model. If it is a joint set where A minus B, this is the only thing that we remain. We omit the common element, and what is only on A would be its difference. On the other model, if we have B minus A, what is only left in B, and we remove now what's common between A and B, will be the answer. So let's have some example on the next slide. So here we have again this example, which is the universal set is 1, 2, 3, 4, 5. So let's have now A minus B. So we have now our A and we have our B. You remove now what's common to them, and what's left on A would be the answer. So therefore the answer is A minus B is 4. So this is the only thing that is left there. Next, what are the elements of B minus A? Once again, you look at now your B and then remove now what is common between A and B, so that the remaining now on set B alone is 2. So therefore, B minus A is 2. And that's it about set operation. I hope you learned something with this one. Once again, there are four operations such as complement, union, intersection, and difference. And then you need to explore this one because there could be mix and match of this operation, but I know you could get it. Thank you for watching this video and have a great day.